Okay, so let's take a look at how you can create pairplot using Seaborn library in Python, right? So first thing, we are going to open command prompt or terminal and make sure that we have Python installed. Once we check the version, we can go ahead and install pip install Seaborn. This is the library we are going to use to draw the pairplot, right? Now what we can do, we can also install Jupyter-lab, right? So once you have these two things, simply type in Jupyter-lab. Once you hit enter, it should run the code and start a Jupyter-lab instance in one of the browser. Open one notebook. Now here we write the code. Now let's see. Import Seaborn as SNS, right? Next thing, to draw the pairplot, we are going to need one data set called iris. So we create a data frame and then pass the data set loaded into that. So iris is the data set that will hold the data into that data frame. So if we use sns.pairplot, then we will use data frame to plot the pairplot, right? Now what we can do is, this is not the only data set we can use other data set as well, right? So your pairplot should look something like this. Notice the scatter plot, histogram, bar plot are part of this. So it will make use of sepal length, width, then petal length, width, and against which this pairplot would show you the output, right? So you can manipulate some of the diagonal plots as well as the diagonal from right, which are your scatter plots, right? So some of the variables that we can change here would be, let's see, we are going to use this pairplot function within which we already passed the data frame. Now the variables I want to change, I want to use them within square bracket. So I will use petal underscore length, these quotes here as you can see, petal underscore width, right? So length and width, and then we run this and the plot would come out, right? We are only manipulating the two of these variables, which should shrink the pairplot into these two. So from the right side, this diagonal view, your typical scatter plot, whereas from the left diagonal it would show you bar plot, and variables petal length and width. Okay, so similarly we can also change some of the color plot and we can adjust them by group. So say if I choose something like, let's say, hue, this parameter if change, then I can simply change one of the variables species, right? And it has managed to draw the plot, right? So here you see, with the species variable change, it will draw the plot that looks something like this. And on the right hand side, you will also get this legend showing those species: Setosa, versicolor, and virginica. So basically these are flowers or plants and it has their own species, and with color code you will find them in a variation with scatter plot here and density plot as you can see in the diagonal form, right? So we managed to draw the plot and then categorize it with the group, right? Similarly, so custom argument we can change here, like say plot kws and diagonal kws, right? So for that, if I choose, let's say I remove this hue, and in next line if I do plot underscore kws equals to the curly bracket and color, then colon, right, and then simply comma again, and then marker, right, and equals to, I will have to pass s, right. So once we have that, can go ahead and add one more comma to this. On the next line, tag kws equals to, within curly bracket, use color, and then colon, orange, right. So once we draw this, notice that the expected of the dictionary key, so marker, so sorry, I managed to use equals to, should be colon. So if I run this, it should show the custom arguments being passed to our pair plot. Notice the change in color. Also my bar plot looks orange, whereas scatter plot would be getting square treatment instead of typical circular points, right. So we made some of these custom argument changes, right. We can also only change custom markers, right, instead of doing these manipulations. See, if I want to use hue and make it for species, in the markers I can simply use, say, T, then P, and then V. 3 different markers, we are passing them here. Let's see if it changes anything. So for each group we are passing these markers. So species, we have 3 different species: Setosa, versicolor, and virginica. You will notice the change in color in scatter plot as well as change in color in density plots, right. If you want to remove the upper panel, you can set the corner to true, so we can remove the marker and corner to true. And if I run this, it should make some of the adjustment to panel as well. Notice that the panel is removed and now we only have diagonal view for the paper plot. Then there are some of the properties that we can change. Kernel density properties specific to a parameter called kind, right. So if I replace this and simply deal with kind parameter, and for that we pass KDE and run this, that should show you the kernel density estimate with kind set to KDE. We can also set the kind parameter to histogram and regression. So if it's set to KDE, it should look something like this. Looks more like contour plot and density plot combination, right. So if I change the KDE to, say, hist, should add the histogram view within our pair plot, right. Notice that the change in histogram in the diagonal view, whereas square tiles in our rest of the plots, right. There is also regression option with reg keyword, and if we run this, it should change your plot as well. As you can see, that change in the plot is also possible here. Then there is also diagonal type. For that we will be changing this diag underscore kind. Here we can set KD. If we run this, it should show you the diagonal type change within our plot. So here we have like dot shaped scatter plot and kernel density plot in the diagonal, right. And similarly we can also remove entire diagonal if you want. So diagonal kind we set to none, right. So let's try this parameter and see if get removed from the pair. Right? Notice that there is literally linear points appearing within our diagonal side, so they tend to be ignored. Rest of the chart remains the same within our diagonal kind KD. The value remains the same here in none, only the diagonal values removed. So this is basically our pair plot. So you get the idea how to draw the pair plot and how to customize some of its properties.